Welcome, everyone. My name is Wayne Van Sluis. I'm an Oracle ACE Director and the lead consultant with Argonaut Interrel. Today's session is Oracle Analytics and Oracle Spatial Studio. And to play an homage to an old commercial from back in my childhood with the people that bump into each other with their chocolate bar and a cup of peanut butter, you get the Reese's peanut butter cup. In this case, I think these two technologies are better together. I mean, they're great alone, but they're better together. They help tell a better data story when it relates to location and spatial. Why are we not advancing? There we go. A little bit about Argonaut Interrel. Our goal is to build strong collaborative connections with our clients to help them glean meaningful insights from their data analytics that ultimately drives improved business performance. Edward Roski liked to say that we're an education company that consults. And I kind of like that idea. So, our mission is to leave the world a smarter place than we found it. I have a background in education. I have a master's with training and development focus, and I love to teach people something new. So with that, Argonaut Interrel has been around for over 20 years. We don't want to go back. Here we go. We're recognized experts in the field. I am one of the 3 Oracle ACE directors in the company. We have another Oracle ACE, Paul Lewis, and then the ACE alumni would be our Robert Gideon. From our books, there's so many that we've written in the world of EPM and BI and S-Base. Take a look out on our website for those, the Look Smarter Than You Are series. We offer a full service of consulting, both strategic assessments, solution consulting, staffing, infrastructure, cloud, training, just a whole host of services that we are very good at doing in terms of the world of EPM, BI, and S-Base. Big time winner of Oracle's Partner of the Year several years in a row. And we have been the most experienced in the EPM world, we think. We were the first to implement S-Base Cloud, the first to implement planning and budgeting cloud, the first to implement financial close and consolidation on the cloud. So we are the first of many of the myriad of Oracle partners to have been able to implement these solutions before others. So today my objectives are, and I don't want to read it completely at you because I think you have an education, but the idea is that I want you to understand how map layers work within the world of analytics. I want to look at how we can connect these map layers, how we can maybe create new ones from existing data. And then what can we do within Spatial Studio? How can we do some data prep there? How do we move the data between analytics and Spatial Studio? And then really, how are we using maps to tell a better data story, especially when it comes to location-based information? So we're gonna start with the current map views in Oracle Analytics. We'll take and look at custom map layers. We'll then take our data and do some work with it over in Spatial Studio, do some geocoding, which is basically making a longitude and latitude from a address. We'll do some analysis, solve a problem, and then we'll bring that data back into OAC to create the rest of our data visualization or our data story. So which is it easier for you to find where property values are clustered? A table like on the left or the map on the right? I would hope to say that the map on the right gives us that better context of relation to each other, but also where, exactly where in the world they are. So in this case, we can see a higher density of our properties in one area, or the higher property values. This is why I like using maps. But maps aren't just geographic. They're not just tied to an address point in the world. We use maps, and I use maps quite a bit when I fly. I don't want to have a real crappy seat, 11B on the plane on the left. Well, 11B, that's a center seat, right? But the plane on the right, 11B is an aisle seat. It's nice. It looks like business class. So if I said, oh, I got seat 11B, it doesn't mean anything until you can see where it is in the relation to the rest of the world of its related partners or neighbors or other data points. So Seat Guru is my go-to when I want to find a good seat on a plane. But this, again, where are you in relation to others? Another place that we use maps would be for looking at a concert seat. Do I want to be behind the stage, in section 329 or 123? I mean, those seat sections don't mean anything until I know where the stage is. What's my best line of sight? Is there someone's head above, in front of me? Usually the floor seats, C, B, and A, they're a little bit lower than the people in the red range, right? If I'm in B in the last section, well, I could be looking at someone's head instead of the stage. So usually I like to go into something like 108, 109, 110 to get a nice straight line of sight and not have to look at someone's head. So we use the maps, go to the theater, things like that to find a good seat of where we want to be in relation to another part of the world. So in the world of spatial data, then, move this out of my way. In the world of spatial data, location is based, on things like the GPS, the address points. Where are they? Where are they in relation to other things? Maybe we're using GPS to get sensor readings off of one of those Internet of Things sensors, and we need to know where that is. So the GPS, those lines, those points, lines on a graph, where point A to point B, the polygons, the shape around something, the arcs going from one airport to another. And this is all stored in the Oracle database. But there's two others that not often are thought about, is the satellite imagery and sensory-based, LiDAR type models, where we're trying to get readings at a point in the area. But then also the networks. We all use Google Maps or MapQuest or something like that to tell us the best route to get somewhere. So that's stored in a database. So network models. How do I get from point A to point B? What are my transportation layers? What are my infrastructure layers? Where are the electrical lines running, or my gas lines running? That can be stored in a database and then used for analysis. But spatial data is about where something is and how it's in some relationships. So, how fast can I get somewhere on a certain route? Who is in my sales territory? If someone gave you a list of addresses and said, oh, go, which one, pick the ones within a mile of you, or, within, 10 miles of a branch office, we would need to do that through spatial. It's hard to do without some kind of analysis of who I am and then where something else is. So the Oracle spatial data lives in the database. It's been part of Oracle database for decades. Up until recently, it was an added feature that you had to pay for, spatial analytics. Probably about 2 years ago, 3 years ago, Oracle decided to make spatial analysis free. And especially when it came to the Oracle Analytics or Oracle Autonomous Database, that's where it really came into play, where we can now leverage calls through easy access tools like the Spatial Studio to this data that is residing in the Oracle Autonomous Data Warehouse. And that data is stored as either a point information or a line information or the shape of an area, and right now even imagery. So we can now create spatial analyses through SQL to find those who are closest to us, those join regions together to make a bigger region, states to create a sales region. But most of that had always been done through developer access and SQL, PL SQL, Java, Python, JavaScript. And then recently with the addition of Spatial Studio, we get this whole self-service or no-code access to that complexity of that kind of analysis. In the past, if I wanted to know how many branches were within a set distance of my warehouse, we had to understand that actual spatial analysis function. And that was left to the developers, to the guys who were code junkies. The common person at the desktop couldn't do this without having to do a lot of self-study. And now we have Spatial Studio that makes it very interactive, very canned. Each of these complex SQL options or analyses are now a click and a drag away. We have the ability to return something with, give me the data points within this boundary. If I go into the map and draw a circle and say, okay, return only these members that are within that circle on a map, that would have been a very, very complex feature to do in SQL. But with the advent of Spatial Studio, all that complexity is turned into API calls, and with a relative few items to select on a menu, you've got yourself a quick and easy access to these complex questions. So Spatial Studio brings that complexity down to the end user in a more self-service way that we're, especially us people working in the Oracle Analytics space, are used to, especially in data viz, where we can quickly build graphs and charts and aggregate functions on data that if we had to wait for someone in the warehouse, the data warehouse team to create a special table and some other pieces. So again, self-service, making it easier to the end user. So just a quick overview of things in Spatial Studio. I'm going to take a quick water here. We work with the concept much like in Oracle Analytics Cloud. We have projects. We have the data sets that we're going to work on. We have the connections to a data source, which provides us the data sets. We can do things with jobs. So if we want to maybe refresh an analysis with new data, we can create a job and schedule it. And then of course, the administrator has some side features that they can do to take care of whether or not things are running too long, things like that. But when we get started, we start with having to create a connection to our autonomous database, our autonomous data warehouse. You can do it with an on-prem database, Oracle as well. We're going to work with the cloud because we're living in the cloud these days. We make that connection. We connect a table or a view from that connection. We can also upload data files, spreadsheets, GeoJSON files, which are shape map layer type of information, or shape files from some secondary source. That information, again, it gets loaded into the data warehouse, into the autonomous database in the spatial schema that we've created, and gets treated in a special way. When we have our data in the project, we can then start to prepare it. So if we have address data, we might want to geocode that address to a longitude and latitude. So we have a geocode option. We can create longitude and some other indexes that need to be special for that kind of back-end work that needs to happen when we want to ask the question of what's within a certain area. So that's part of the prepare part. We have to create this geocoding on an address. We have to put an index on the table. And then once we have our data, we can take it, drag it from the data sets onto the map layer, and it's rendered visually for us right there without any major coding. It's all click and drag. when we want to start asking some of those questions, then we have the ability to say, okay, tell me who's nearest to me, right? Nearest neighbor. Return the shapes that have, within so many distance of each other. So, if I can set, I want to find something within 50 meters, here's those that are there. Whereas I can say, out of all these people, who's the closest to me? Find, again, if I want to draw a circle on the map, I want to know who's within that circle or who's outside of that circle. And so we have all these advanced features that would have required complex SQL statements to happen, now available to us at the click of a button, pretty much. And then we end up with our end result. So this is going to feed into the demo that we're going to be talking to next on using some of these analytic features within Spatial Studio. But while we're within Studio, it's just like within Analytics, we can save the project, share it to someone else. We can export that data. We can, maybe if we're looking to create some automated processes, we have all the underlying SQL that took place if we want to recreate, or we have these GeoJSON endpoints that we can use to put a display in a secondary or outside of our world of the cloud, put that endpoint on, and I can have it displayed on another web. So how do you get Spatial Studio? Well, it's included with the database at no cost. So for on-prem, if you're wanting to work with Studio, you can run it from the actual application. You can run it from the Oracle Cloud Marketplace, or you can download and run a little self-contained version on your desktop, but you still need a backend database somewhere. Right? So there's a Studio component that runs either as a web service, or you can use the Cloud Marketplace version, or you can run it locally on your desktop if you've got enough horsepower for it. But again, the Studio requires a backend database, whether it's the cloud or an on-prem. I've even actually used the Oracle Express database as my database for Spatial Studio on the desktop. So not overly complex. So here's the demo. It will speak to a concept. I have St. Louis properties that are, I used a website called Macaroo to get legitimate addresses, but everything else in this is fake. All right. So I've got 100 addresses or whatever it was, and we've got some made up property values to just give us some disparate, different data points and values to those data points. So we're going to show the video of this because now I've learned the lesson. Don't try to do a live demo because you get the gremlins. So we're going to start with the insurance data. We'll take a look at it. Again, this is Macaroo. I went and just had them generate a list of addresses within the St. Louis zip code or the St. Louis metro area. And we have all the properties. And then I created a random number generator using the same ID, but for an insured value. So now my insured value is just fake, but the address points are real. So we'll bring these into DataViz as an upload Excel file. First, we're going to get the data from my spreadsheet, right? So there's my data. I'm going to look at, I've got a column for my ID, my zip code. I'm going to change that from a measure to an attribute because I don't want to sum up address my zip codes. I just want to display them, right? And part of the data prep is that I can profile my data, take a look, and especially when it's location-based, I can convert that to location. And if there's a map layer that supports it, like zip codes, I can align it to the zip code map layer. Now, there were some zip codes in there that did not recognize, so we won't see all of them as a map view. And my zip code layer needs to get updated. So again, we're going to bring in the property values as one more. data set. We'll call it our insured properties. And we'll create a project. So we have our insured properties. Now we'll add the secondary data set with our insured, the actual property addresses. And we can look at, so what's my total insured value? Insured value is 78 million and change. All right. Now, if I bring in the zip code, because it's already, and along with my insured value, because the zip code was tagged to the map feature, it knows to build a map. The only thing it didn't know is we need a nice background map. So those shapes are the zip code boundaries in St. Louis for the ones that were in the polygon. So here we can see those values by zip code. So we can see that the Maplewood zip code area has got the highest property insured value. All right, second area would be up there in Bell Ridge and Normandy, and then the Sunset Hills would be the next. And then if I want a count of my properties, because I'm not just bringing in the field in wasn't giving it to us, we'll just do a count of the ID column, or a count distinct of our ID column. And it is unique, so I could have just lived with the count. We now have a count of properties, so we know how many properties we have, what their insured value is. And that's great. We've got a start of a map. If I asked you, just giving a list of the properties, where's my highest value, you'd had to sort it and look for the cutoff points. This way we can quickly see it on a map. Okay. So what were the steps that we did inside OAC? Was we imported the files, we imported the insured value, we imported a zip code layer that I picked up off of a publicly available website. I set my location details on the zip code, and I created a visualization showing you the zip code with a couple of different views of that data. So what can we do with this data? We've got 360 properties. We know what their values are, but we couldn't see where they are on the map because it's not been made available to us as a point layer, right? So that's what we're going to do in Spatial Studio. So in Spatial Studio, again, it's web-based. We're going to sign in. And I'd like to acknowledge my good friend, David Lapp from Oracle. He's the product development there. He created this set of videos, and he and I co-presented at Kscope on it. So here we're going to create our connection to our instance. We're going to bring in our wallet file to make that connection between our web services. And we'll log in. Right, so now we have a connection in our autonomous data warehouse where we're going to be storing our spatial data, our data sets, everything gets stored in the data. So here we'll bring in the spreadsheet of the insured data. Okay? And we'll take a look at, again, it's a similar data prep that we did in Oracle Analytics Cloud. We're going to change that zip code to a string. We're going to store it in a table on a connection. And we have it now getting uploaded. Now this data is ready, not quite. It's telling us there's something wrong. All right, so we can see that little triangle on the data set. That's telling us that we have to do something. One, that we don't have a key column. All data in spatial analytics likes to work from a key column, a unique key, so we have to create one of those. And then the next one is that we want to do something else with this data. It notices that it has addresses, so we can geocode that address. So we can look at the data and say, okay, yes, this works. We have an address, a city, a state, a zip. We're going to just geocode it. And we just like that. It's running the backend service on the or ADW. And it's looking those addresses up, finding longitude and latitude, and generating those points into the data. Now we have a geometry column in our data. Now, part of the question of this process was, where are my possible, we've got an issue where there's a storm coming. What's the potential for flood? What properties are going to be impacted by this flood? And I pulled the data set from St. Louis County floodplains, and that's going to be shape data. It's not point data. So it's the areas that are going to be impacted or that are flood prone, right? So we're uploading this flood hazard data. We're going to have to give it a legitimate table name. And then I want to prefix it with my STL so I can just find it easier. There's my flood hazard areas. Now these are, again, polygons. They're shapes around like an area on a map. And in this case, this data set wasn't able for us to get a good coordinate system. So we had to go look into that file to find out which one it was. And a coordinate system is basically how is it going to display the data relationship to longitude and latitude. So we've assigned it the proper coordinate system, and it's bringing it in. Again, we've got a little bit of a warning, and that warning is telling us that we need a unique key. So again, all data within spatial analytics requires a unique key. So we've assigned that. So great, we've got 2 data sets, and now it's time to do some self-service. So we're going to create a project using those 2 data sets, and it's just this easy. We take the data sets from our data elements panel, and we just drag it over into our work area. And because it's related to map, and this is a spatial tool, it knows how to present that data. So we now have our addresses coming on as red dots, our floodplains coming in as that pink with a blue line around it, and now it comes time to be a little bit more artistic. Let's take this data and make it easier to understand, read, and view. So I'm going to change the color of my address points to a kind of a brown orange, and I'll make them really dark in what they call the opacity, instead of kind of so that you can't see through. And then my floodplains, I want to make it something a little bit easier to discern as well. I'm going to get it to a nice dark blue. And no border. And there we go. We've got a nice blue data points and background maps. We've got a choice of background maps. And in this case, I would like a nice kind of positron view because I don't want to see all the background. I just want to know kind of the background relationship to roads and other rivers and things like that. So now comes the question of what properties are within a region, all right? So we're going to say return the shapes within a specified distance of another. And what we want to do is we want to filter our data. So we're going to create a new data set, all right? This is my at-risk properties. These are the ones that may be within a region. We're going to filter my insurance data by using the map layer of my flood hazards. And we want to look for those within 50 meters. So I'm saying, give me any properties within 50 meters of a flood hazard. And we want those to be a new data set labeled at risk. So it's running in the background. This is a small data set, so it's a pretty quick run. So now we have a data set analysis called insured data at risk. We can bring that onto the map. And as we bring it on, it puts it at the top. And we can see it kind of right there as a red dot, but maybe it's better if we do something more with the colors of our other layers. So let's clean it up a little bit. Let's take that insured data to make it less bright so we can see more of that red, right? So now we have ourselves a nice set of output. We have our insured properties as address points. We have our at-risks as address points, and we have that map layer. And as we zoom in, we can actually see, yep, there's that dot, that red dot, really close to that floodplain area running through that part of the city of St. Louis. So we're going to save this because we may want to use it later, and I can always add to it or refresh the data with maybe new addresses as we get them. Now, we've been working using just regular data files from the input. We could have gone off of database table as well. But here, now, again, because it exists in the database, I could connect to it with OAC. But I still need to create map layers, custom map layers. So I'm going to export the flood hazard area with the geometry and the object ID as a GeoJSON. So now I can have a custom map layer. I'll export the data for that same area, just as data, in case we may want to use that for informational purposes. Because if I want to show a map layer as an interactive, I have to have a data layer with it. So that's why we did that. Here I'm going to export my insurance data as a GeoJSON layer. And all I need is just the geometry and the ID, because I need something for my OAC data to marry up to the JSON map layer. So I'll save that out. One more export of just the raw data. If I wanted to use it separately. And then finally, my at-risk data. I need this back to help continue to tell that data story. So we'll export the St. Louis insurance data that's at risk. So now I have some data sets to work with back in OAC. So we're done in Studio. And it's time to take the next step. Again, just because videos don't go out in PowerPoint decks or PDFs, these are the steps that we followed. We imported the property data to Spatial Studio. We geocoded that property data. We did some spatial analysis to find them within a meter. We've downloaded the data file. We downloaded the GeoJSON files. Actually, I should have put in here is we uploaded a shapefile for the flood area. And then we have a couple extra data sets that we can work with outside of Spatial Studio and make it useful. So in the world back to OAC, we're going to bring in our data. So we have a little bit of ingestion or uploading to do. One, we want to go get that map layer. So we have to go to the console into our maps and add a custom map layer. This is going to be that JSON export of the insurance data. This is all our address points. All right, so we have something in our data to link to make a display of our address data or our insurance data. So let's open up that map project again. We'll duplicate the view. And in this case, we're going to come in and bring in the map ID. And I forgot to change the data type. So we reshot the quick. That my map ID is now tied to location. And if I drag that map ID into the data, I will see now points by property value. Now I can see the density of property value, right? Higher values are darker colors. I can change it into a cluster. Where are my properties clustered? You can see the 39, 18, or a heat map. Where's the density by value, right? But this isn't the question we asked yet, is it? The question we asked is what is impacted by a flood? So we need to bring in another data set, and that data set is going to be our at-risk data. And this was, again, we could have gone to a database table. This was working within the context of data files being shared. One thing to note is I added a column called area, just to make it easier to work with the data. And when longitude and latitude are identified there as numbers, we need to convert them over to attributes. We don't want to sum up a longitude or a latitude. We want to use it as something to describe the data. So this data is now profiled in Analytics Studio, Oracle Analytics Cloud. We can see that all our data is the at-risk. We can see other parts like male, female, the address points. It's basically the same data, except filtered down from the 300 and some odd to now just a little over, I think, 60 or 70. So we need to change the relationship between our insured data and our at-risk data to be joined on the ID. And now we'll duplicate this canvas because it's always good to tell a story in progression. So we'll duplicate this canvas, and now we take a look at the count of properties. Instead, we have, again, back to a point map. And here I'll bring in my at-risk as my filter. And we can see, actually, we're going to change the color. So the at-risks are green right now. The other properties are blue. We're going to edit the color to find them a little cleaner and easier. So we'll make that a red. These are my at-risk, right? Nice bright red. And I can easily see at-risk properties out of, in my 360 properties, and here's my value of 7.1 million. Well, how about we get a value of what those properties are? And we'll just use some of the features within Oracle DV here to get there. So here's my insured value. I've filtered that viz based on the at-risk. This creates an inner join. There you can see out of the 78 million, I got a little over 6.5 million at risk. Now, the one part is that this count didn't want to behave properly, so we had to look at it a different way. It did not want to enforce an inner join on the count. So we need to, because of the calculation, so we'll just take a filter on the count and use all of the IDs that were within the at-risk. And we see that there are 31 properties with an insured value at risk of about 6.5 million with the potential for flood. Now, we'll save this here, but I want to speak to the custom map layer feature that came, I think we're in 6.2, like around 6.0. 6.1, I could actually show you the floodplains now. I had issues trying to make it work for the demo, but we could actually put that as another layer on the background and show those flood regions if it was really necessary for that data story. And maybe something I'll do a blog post on to clean that up. But the critical part was, how do we get to this, finding those properties at risk from a flood? It would be almost impossible if we didn't have Spatial Studio to do that kind of analytics. And I could swap out the floodplains. I could go to a higher flood areas, or some other interest fact. Maybe I want to look at those, put my addresses of my regional offices throughout the state. How many properties are within 2 miles of that office? Again, that's a spatial analytics feature. So again, what did we do on the OAC side? We imported the GeoJSON. We joined it to property data. We displayed the address layer. We imported spatial maps. We displayed that, and then we used the spatial analysis map layer to filter our insured value to show how much of our portfolio is at risk. And for me, just as a final map clear up, I put my regular properties as a gray because I really don't care about them. I want to know that they're there, but I just wanted to kind of put them in the background and then really accentuate the at-risk give me that big pop of red. And this would be a great, something that just as a quick boardroom meeting, here you go. This is what, this is what we have at risk with the next storm coming through, whether it's a hurricane or tornado, whatever. I like to leave people with files if they're interested. And if you are, you can email info@Interrel and ask for the data files. It's all mock data anyway. I'd be willing to share. The flood area that we used in Spatial Studio was from St. Louis County Gov. So you can download it, follow the QR, get you there. I've seen a similar demo done with the path of a tornado or a path of a hurricane. I just wanted to stick close in the St. Louis area because that's actually where I live. So for me, it was a great way to tell a story. The analytics Geo Layers, I don't know if these exist anymore in the Oracle Analytics library. I went looking for them the other day and they aren't there. So I have to check on that. They may be somewhere else now. Getting started, I would recommend looking at some of the Oracle Analytics Cloud tutorials, and as well as Spatial Studio has a live lab that you can work with. And then of course the YouTube videos I need to update, as I think 1 or 2 more things came out with spatial analyses in 6.1 and 6.2. The non-joined data sets is the big one. Custom map layers, assigning map layers. There's all of these playlists that tell you some neat little features on how to get things done in maps on Oracle Analytics. Some other quick resources, I won't read these all to you, but they're in the deck and you can look for them. Again, map layers, visual, downloadable files to help you, maybe the boundary layers for certain things that you're interested in your business related to it. And maybe not United States based, you can go to those that are out to the rest of the world related to maybe different parts of the globe. Again, some great resources for shape files, which are the boundary shapes. And then one that I've really been interested in is the idea of using map services. Weather changes and putting a polygon up of a map is tough. So maybe using a map service as a background, as the weather comes through. So again, even FEMA declaration areas. So if you want to, they finally posted, here's the tornado that just came through. Here's the path of it. Here's the shape file of that tornado. You could then quickly, use it to find out what you have in assets that might be at risk. Maybe it's delivery paths. If you've got logistics, supply chain, and you're like, wait a minute, this storm is coming through here. It's going to impact these roads that may impact our deliveries from hub to hub. All right. So with that, I hope that gave you a better idea of how to leverage both Oracle Analytics Cloud in spatial world of data, but also how to take them and add to your tool belt Oracle Spatial Studio to help tell that other part of the story and to help ask questions with data related to space and relationship. We are at 1:46, right around where I wanted to be on time. And I'm ready for questions. I have some time. Yes, the deck will become available. I think Brianna will be posting a link to it. As well as I believe we share all our recordings of these sessions. So with that. One thing I'd look at, Carol Palmer and David Lapp from Oracle Product Support have been posting blogs on some of the newer features that have come out in Spatial Studio. I think one of the latest ones that I really like, David Lapp, Justin, David and I worked together for the K-Scope session, and then I just soloed this one today. His video is what's embedded for the Spatial Studio component. Part of the new features of Spatial Studio is to create a new map layer from existing data. So think of the United States as 50 distinct states, but maybe I want to create sales regions by picking, different states together. With Spatial Studio now, you can actually create new region layers, which is really cool. And I don't remember, Carol posted something on LinkedIn to a guest blog post, and it's pretty slick. I think of, making those custom sale regions as another map layer for telling your business story. I'll stay on for another minute or two for any other questions. It doesn't look like there's any right now. Again, if you have a question on this that bubbles up to you later on, just send it to info@interrel.com, info@interrel.com, and it will get directed to me and I can respond to that. One thing I'd like to point out, we have some more webcasts coming up and conferences. Today was the Oracle Spatial Studio and Analytics. Next week, the 27th, we have the Freeform Apps and EPM Cloud. What is it and can it help me? We also have our Customer Success Forum, Cabot Oil and Gas on the 28th. November 2nd and 3rd is the Oracle, the Hyperion Solutions Conference at Interrel is regenerated. Last year was a great success, and we're hoping for great momentum into this next year with it. Lots of great content, great speakers. I will be speaking with a fellow consultant on a topic of data viz and data storytelling. And then mid-November, we have a bunch of public training classes that'll be coming available. So keep an eye out for the newsletters coming from our marketing team and are on the website. So with that, I thank you all for your attention this afternoon. It's been great. Go out there and make some awesome maps. I think it's a fun tool to work with, and it's really not that difficult. It's a whole lot easier than what it used to be for me years ago when I had to make custom regions and do the analytics using SQL. So again, thank you very much. Have a great afternoon. Goodbye.